The most common way to change the voltage of an AC signal is to use a transformer. So here is a picture of a transformer, and it has two wires on each side. So one side is the primary side and one side is the secondary side in order to change that uh, AC amplitude. So let's go look a little bit about transformers. So here's what the transformer model looks like. And you see, first of all, it has a dot to tell you what the orientation of the signals are, and it has a voltage and a current, a voltage and a current. So over here, you can see the equation. So the equation is the ratio of the voltage on the primary and secondary side is the inverses of the currents, and then this is going to be related to the inductance of the two coil sides. So you can kind of see one side has more windings than the other side, so we end up getting the ratio of the voltages is equal to the square root of the ratios of the inductances of the two coils. So we want to be able to model this equation and this structure in LTspice. So let's go to LTspice and see how this is done. So the first thing is that the two coils are inductors. So we're basically just going to grab two inductors, flip them around so that they kind of look prettier. And then here we make this the primary side, we make this the secondary side. And this one, we're just going to pick a large inductance. We'll pick this to be 1 millihenry for inductance. So let's say we wanted to do a 10-to-1 ratio. So then we're going to take that the 1 e to the minus 3 divided by a 10-to-1 ratio, but because of the square root, that's going to be 100. Okay, let's convert this into micro. Okay, so then we have L1 is equal to 1 milli, and L2 is equal to 10 micro. So you see, if we did the square root of L1 over L2, you see there's our ratio of 10. So we want 1 millihenry and 10 microhenry. So over here, we're going to make this 10 microhenry. Okay, so then we're going to add in a voltage source. Just to make this nice and easy, we're just going to make this 100 volts with a 60 hertz signal. Go ahead and add a resistance over here. Let's just pick 1 kilo ohm. And then let's wire this up. So we're just going to wire all of these up like this. Throw these grounds in here. Okay. So first of all, with this, it says series resistance defaults to 1 milli, but it's good to put in a little bit of resistance just to not use the default. Okay, so here is our basic circuit, and I have these two inductors. But LTspice doesn't know that these are coupled together in a transformer, so we need to tell it that these two are a transformer. So this is done with a K statement. So we're going to go hit S to pull up a spice directive, and we're going to do K, and then tell it the primary side LP, the secondary side, and then it has a coefficient 1. 1 means an ideal transformer like we're doing with no stray inductance. So we do that, and then throw this up here, and when we did that, you see it added in dots. So if I go back and look at this transformer, you see here are the dots up here. So we want to put our two dots equally up here on the top. So we're just going to take these and rotate them around and then mirror them. And that's Control R and for rotate and Control E for mirroring. And now here is our circuit. So now let's see if this worked. So we're going to come in here and put in 1/10 of a second. And we will run this, and we look on this primary side, and here's our 100-volt signal. We look on our secondary side, And here is our signal here, and you see this is 10 volts, so it worked as perfectly as a 10-to-1 transformer for us, and that's how you model transformers in LTspice.